Hello, this is Mr. Collier, and today we're going to be looking at scientific notation, also known as standard form in the UK and some other regions. Okay? Um, so standard form is very useful for writing very small and very large numbers. For example, this very large number of 6,550,000,000 people in the world. This can be written in standard form as 6.55 times 10 to the power of 9. Alright, so notice the decimal always goes after the first significant figure, and then you have times 10 to the power of some integer. Okay, this gives you some idea of the magnitude. 10 to the power of 9, that's in the billions, so you know this is in the billions. Okay, larger is this number, the larger the number is. Alright, so a very small number, same thing, so you can write the size of a virus here as 1 times 10 to the power of negative 7. Okay, so don't count the zeros or anything like that. We didn't count where the decimal moved. The decimal is now here. So the decimal point went 1, 2, 3, 4, 5, 6, 7 spots. So it has to be negative 7. So if you see a negative exponent, it's going to be a very, very tiny number. Alright, so it's a little bit confusing that in some regions it's called scientific notation. Sometimes it's called standard notation. So that's why we have a mathematical definition. Basically, we mathematicians will talk about this form as a number in the form a times 10 to the power of k, where a is greater than or equal to 1 and less than 10, and k is an integer. Okay, so this is the formal mathematical definition of standard form. So notice here we have equality. A can be 1, like in this example, 1 times 10 to the power of negative 7, but it can't be 10. It can be 9.999 or something, but it can never be 10. If it was 10, then we'd move the decimal back and we'd have 1.0. So if you have 10 to the power of, or 10 times 10 to the power of negative 7, like that's not in scientific notation or standard form. Okay, you would write that differently. Alright. And k, of course, indicates that this has to be an integer, so it's an integer, positive or negative number, sometimes even 0. So here's some steps for writing a number in standard form. Rewrite the number with the decimal point after the first non-zero digit. Count the number of places that you shift the decimal point, and write as a power of 10. If the number you start with was less than 1, a very tiny number, then you're going to have a negative exponent. Okay, so here are some examples. We put the decimal after the 3 here, so that would be moving the decimal 5 places, so we have a 5 here. Here we have to move the decimal 4 places. 1, 2, 3, 4. So it would be, and it's a very tiny number, so it's 10 to the power of negative 4. And yeah, here's a couple of examples as well. Alright, so write the following in standard form. So we have 1, so we need to move the decimal in after the 6. So 1, 2, 3, 4, 5 places. So 6 times 10 to the power of negative 5. And here, 1 light year is this many kilometers. Alright, so we're going to move the decimal point to here. So that would be, let's count groups 3. 1, 2, 3, 6, 9. We will move the decimal a total of 12 places. So it's 9.46 times 10 to the power of 12 kilometers is 1 light year. Alright, the following is ordinary numbers. Distance from North Pole to the equator is 1 times 10 to the power of 7. So I start with a 1, and my decimal will be right here, and then I have to move 7 places and make it a very big number. So 7 zeros are going to come up. 1, 2, 3, 4, 5, 6, 7. So that's actually, is that the right? Oops, I put the commas in the wrong spot. Looks like about 10 million. Yeah, 10 million. 10 million meters. Thickness of a layer of oil is 7 times 10 to the power of negative 7 centimeters. So here we start with, I'll start with a 7. Okay, and here's the decimal point. I want to move 7 places, so it's going to go 1, 2, 3, 4, 5, 6, 7. And here's my new decimal place. And I'll put a 0 in each one of those blank spots here. Okay, so notice that I have a decimal point and then 6 zeros and then a 7, so all you that's 7 places. So it's a very tiny number. Okay, you can also check out scientific notation on your calculator. Alright, so to get 3.298 times 10 to the power 4, well, you can type it out like that, but you can also do 3.298, and then this e symbol right here where the comma is, so second function e 4. So that means the same as 3.298 times 10 to the power 4. Okay? So it gives you that number. Alright, so and the next one you can also type in just -7 and it'll give you the number of scientific notation. Alright. Now, if you want to do calculations with scientific notation, it's a very good idea to put each number in brackets. You don't always need it. Like in the first example, you don't actually need the brackets, but you can see it better. You can see that you're multiplying this quantity in scientific notation times this quantity in scientific notation. Okay, if you want to cube a number in scientific notation, then put it in brackets and cube it. And we have various other types of calculations here. I'm going to do this one right here in the calculator to show you how to do that. So if you have a big giant fraction like that, I like to use alpha and then this number over here. So the first one here gives you a fraction. Alright, so you can type it all out and almost exactly what it looks like. Now you don't technically need the parentheses, but I'm going to put them in there anyway. So 3, now we don't need times 10 to the power of 14, I'm going to do e. Okay, it says e14 plus 5e11 so we have 4, and then at the bottom we have 4e to the power of -5. Or actually, sorry, don't put it on to the power of. That is not correct. 4e -5. Okay, and you get this number. You get 7. Now we can write that down as, I'll use 3 significant figures, 7.51 times 10 to the power of 18. 7.51 times 10 to the power of 18. Okay, let's take a look at what's next here. So those are the answers actually. And well, these examples we just need to do like we did before, write in standard form. Okay, well actually, these are not quite in standard form. So we have 46 times 10 to the power of 11. So we need it to be 4.6. Okay, so what we did was we made this number smaller. So the exponent part has to be larger. Okay, this one is already in standard form. This one we need it to be 8 times 10 to the power of something. Okay, this needs to move 1. So we made this number bigger. This exponent has to be smaller. Here, this is already in scientific notation because this number is between 1 and 10. Here we need 8.92. So I made this smaller by a magnitude of 2. So this number has to get bigger. Okay, and then over here we have 9.4. This is already in scientific or standard form. Alright, express the following in decimal form expanded. Alright, so express it in decimal form. This would be 9600, and this, well, I'd start with 3.67 and I move 1, 2, 3, 4, 5. Okay, the next one, this is just actually equal to 1, so it's going to be 6.23. And here I'm going to move the decimal has to go here, right? So it has to go 4 places. So 8.95 times 10 to the power of 4. Here the decimal has to go 3 places. 7.06 times, now this is a small number, so it's -3. Here the decimal has to go 2 places. 5.569 times 10 to the power of 2. And write this in scientific notation. I guess I can just do 7 times 10 to the power of 0 to write that in scientific notation. Now notice, we use scientific notation in part 3, and we do standard form in part 1. They both mean the same thing. A number a to the power of k, such that a is less than 10, less than or equal to 1, and k is an integer. Alright, so next, write these in increasing size. So they're going to be increasing. We need to put the smallest one first. Alright, so look at them. Actually, it's very easy to compare if they're all in scientific notation or standard form. So let's switch them all first. So this one is going to be 1, 2, 3, 4, 5. So that's 4.6 times 10 to the power 1, 2, 3, 4, 5. 10 to the power -5. This is going to be 5.6 times 10 to the power. Now I need to make this number smaller, so the exponent gets larger by 1. And this is 7 times 10 to the power. I made this bigger, so this exponent gets smaller. And this is actually, okay, 10 to the power -4 is actually going to be 0. Actually, we can write this as 1 times 10 to the power -4. So the smallest one here is going to be the smallest power of 10. So actually there's 3 of them with -5. So we need the smallest number, so it's going to be 3. Let me just write this in order this way. So this is going to be the first one, smallest one. Then looking at these two, this is the second one, and this is the third one, because that's a bit bigger. And looking at these two, well, 1 is smaller than 7, so that's the correct order. Okay, so here we're going to do these operations. Alright, so here you would do just 1.5 times 10 to the power 4 times 4 times 10 to the power -2. You can do that on your calculator. Same thing with all these other ones, actually. So I'm going to skip that for now and go on to a couple word problems. Mass of a hydrogen atom is approximately this amount, and that of an oxygen atom is approximately this amount. Find the mass of a molecule of hydrogen peroxide consisting of 2 atoms of hydrogen and 2 atoms of oxygen. So 2 of each. So we need to do 2 times a hydrogen atom, which is 1.66 times 10 to the power -24, plus 2 times 2.66 times 10 to the power -23. So we can work that out on our calculator. Let's try that. Okay, so I'm going to do it exactly as it looks here, pretty much. 1.66, and I'm going to use my E notation. -24. Oops, I forgot the plus sign. So plus 2 times 2.66 E to the -23. And it puts your answer in scientific notation. 5.652. 5.652 times, what was that number? 10 to the power -23. Okay, so it puts your answer in scientific notations and everything. That's good, it's grams. Okay, a packet of seeds weighs 50 grams. A gardener finds that the weight of 30 seeds from a packet is 6 times 10 to the power -2. How many seeds are there in a packet weighing 50 grams? Alright, so the gardener finds that the weight of 30 seeds is this. So we need to basically take 50 grams and divide it by 6 times 10 to the power negative 2 to get how many seeds there are. Okay, so that's 10 to the power negative 2. Alright, so let's do this fraction again up here. This is 50 divided by 6 e and negative 2. So there's about 833 seeds in there.